Hello friends, today I will discuss the LVDT sensor. This is also called a linear variable differential transformer. So its principle is based on the transformer. In this case, we cover what is called the necessity of this construction principle and the graph between output voltage versus distance traveled. What is the necessity of this? The purpose of LVDT is to measure the linear distance from the sensor Here linear distance means it is displacement, that is also called magnitude, that is also called the distance traveled. Direction means, so the moving iron moving from left to right or right to left. If the moving iron is moving from left to right, then we call as positive, and if it is moving from right to left, then we call as negative sign. The construction of this LVDT is like this. There is a tube, and in that tube at the center there is a core called moving iron core, and this moving iron core is connected to an object which is non-magnetic and whose displacement is to be measured. So under normal conditions, the moving iron is at the center of this tube. So this is one winding, this is called the center winding, this is also called the primary winding, and connected to the AC supply. With respect to this primary winding, there are two coils. This is called secondary coil 1, and there is another coil called secondary coil 2. This secondary coil 1 and coil 2 will have the same number of turns, but they are connected in series, and also the induced voltages in them is such that they oppose each other, and the output voltage is measured between these two secondary coils put together, that is between these two terminals. The real diagram looks like this. This is the LVDT sensor. This is the iron core, and this is the object connected to this iron core, and whose displacement is to be measured with the LVDT. This is called the core extension. This is also called non-magnetic material, and this is the housing, and this is the tube, and this is the secondary coil, and this is the secondary coil 2, and this is the primary coil. And this moving iron normally is symmetric with respect to the secondary coil 1 and coil 2. So here the moment of the moving iron will decide how much distance is traveled in which direction by the object. The object means this non-magnetic material which is connected to the moving iron. When it comes to its operation, under normal conditions, the moving iron is at null place. That is like this, means it is totally associated with the primary coil like this, and this position is called the null position or reference position of the moving iron. Under these conditions, the voltage applied, AC voltage applied to the primary coil produces the current in that, and as a result a flux is produced in this moving iron. This moving iron flux links with the secondary coil 1 and secondary coil 2. So since this moving iron is symmetrically placed with respect to the secondary coil 1 and secondary coil 2 under null conditions, the induced voltage in secondary coil 1, which is called V1, and in the secondary coil 2 the induced voltage is V2, values are the same as their number of turns are the same. So the net output voltage is measured between these terminals, that is V2 minus V1. So as V2 and V1 are the same, so the net voltage is 0. That net voltage 0 represents the moving iron is at the initial position or in the reference position or null position. Now the operation of this can be explained like this. Suppose the moving iron moved towards the coil 2 like this. In that case, the flux of moving iron linked with the secondary coil 2 is more, so the induced voltage in the secondary coil 2 is more than the induced voltage in the secondary coil 1. Then the net output voltage will become V2 minus V1, value becomes some positive value because V2 is more than V1. So the positive value magnitude depends upon the moment of this magnetic iron core. So more the moment from left to right or from null point to the right side, then the voltage induced in the difference between V2 and V1 also more. If it is less, means its moment is less. So the positive sign indicates the direction of the moment of the moving iron, whereas the magnitude of the output voltage will indicate the magnitude of the moment of the moving iron from left to right. Similarly, if the moving iron moves from null position towards the coil 1, in that case the induced voltage or the magnetic flux of the moving iron linked more with the secondary coil 1 compared to the flux linking with the secondary coil 2. In that case, as the number of turns in both the cases, means secondary coil 1 and secondary coil 2 is the same, the induced voltage in the secondary coil 1 is more than the induced voltage in the secondary coil 2. Then the net output voltage, as we have seen, because this V1 and V2 are always opposite with each other, output voltage will become V2 minus V1. As V1 is more, so the value net output voltage will become negative value. The negative sign indicates the direction of the moment of the moving iron from right to left, whereas the magnitude of the voltage indicates the magnitude of the moment of the or displacement of the moving iron from right to left. The same thing can be seen here. This is the primary coil and this is the secondary coil 1, this is secondary coil 2. This number of turns here and here are same, but they are magnetically opposing connection and they are connected in series, but the induced voltages in them will be in opposite directions. So the sign will be different, means opposite to each other. And this is the primary winding connected to the AC supply, and this is the iron core or moving iron core, and this is the object connected to the moving iron core whose displacement is to be calculated using this, and its moment direction and its magnitude of moment is decided by this net voltage output at the secondary terminals or secondary. So this same thing is written here. Null position means the core is at the middle of the tube, so that is called null position. And displacement means the moving iron moving towards coil 1 or coil 2. If it is moving towards coil 2, the net output voltage will become positive. and the direction of the movement of the iron core is from left to right. So if the direction of the if the output voltage is negative, in that indicates the direction of the moving iron is from right to left, and the magnitude of the voltage will decide the magnitude of the displacement from right to left. And when we draw the graph between the net output voltage at the secondary with respect to the distance travelled by the moving iron or the object connected with the moving iron, is shown like this. If the output voltage difference of output voltage is positive, then the direction of movement of the moving iron is from left to right. If the output voltage is negative, in that case the direction of movement of the moving iron is from right to left, or from null point to the towards left. And applications are measuring the linear displacement, force, weight or pressure, and its range is plus or minus 2 mm to plus or minus 400 mm with respect to the null position. This is used for measuring the oil position in the cylinders